Hello, I'm Carlos Rosa Suarez, and this is the CRS channel. Today we're going to continue with the geometry problem. For a circle circumscribed to a triangle, the product of the lengths of any two of the sides of the triangle is equal to the product of the diameter of the circle and the altitude traced to the third side. I'm going to continue with the case of the acute angled triangle. Now, from the last video, we were working with the right angled triangles ABE and AFG, from which we obtained that the sine of alpha was equal to HC over B for triangle GF, and was equal to HB over C for right angle triangle BEA. We also had that for triangles BGF and BDA, sine of beta was equal to HC over A, and also equal to HA over C, lowercase c. And for triangles ADG and only for that triangle we had that the sine of gamma was equal to HA over B. Also, for triangle GEB, we had that sine of gamma was equal to HB over A. So for triangle GBE, sine of gamma was equal to HB over A, and for triangle GDA, sine of gamma was equal to HA over B. Those were the 6 relations obtained for the smaller right angle triangles. For the bigger right angle triangles, which were right angle triangles BGG prime and AGG prime, we had first for BGG prime, we had that sine of theta 1 was equal to A over GG prime, which is the diameter, or D. In this case, this D diameter should be understood as being different from this point D. Okay, for a right angle triangle AGG prime, we had that sine of theta 2 was equal to B over GG prime, that is B over the diameter of the circle, or D. Okay, those were the relations obtained from the right angle triangles. We also knew that alpha plus beta plus gamma, that is the 3 angles of the triangle, the acute angle triangle BGA or GBA or AGB, the 3 triangles, that is the sum of the 3, A plus B plus gamma, alpha plus beta plus gamma was equal to pi. Now we have to remember that gamma was equal to gamma 1 plus gamma 2. Now gamma 1 was angle BG G prime, and gamma 2 was angle AG G prime, which means that gamma 1 was equal to pi halves, that is the right angle here, gamma 1 plus theta 1 equals pi halves, as they are complementary angles because the two add up to pi halves, since remember that since triangle BGG prime is a right angle triangle with the right angle being angle GBG prime. The same way, theta 2 plus gamma 2 equals pi halves. So we have that gamma 1 equals pi halves minus theta 1, and gamma 2 equals pi halves minus theta 2. That means that alpha plus beta plus pi halves minus theta 1 plus pi halves minus theta 2 equals pi halves, which means that alpha plus beta minus theta 1 minus theta 2 equals 0, which means that alpha plus beta equals theta 1 plus theta 2. Okay, now we have the sines of the angles, and we have a first relation between the angles, which is given by alpha plus beta equals theta 1 plus theta 2. All we need is the relation, the second relation, so that we can determine alpha and beta in terms of theta 1 and theta 2, because this allows us to relate the ratios corresponding to the respective trigonometric functions. So we take triangle BCA, which is an isosceles triangle, because CB equals CA, which is equal to the radius of the circle. So angle CBA is equal to angle CAB. Okay, so CBA equals beta minus gamma 1. That means beta, that means angle GBA minus angle GBC. Remember that GBC is gamma 1 because triangle CBG is isosceles, because side CG equals side CB. That means that both are equal to the radius of the circle. That means then that gamma 1 equals angle GBC. And since CBA equals GBA minus GBC, so that means that angle CBA equals beta minus gamma 1. In the same way, we have that angle CAB equals alpha minus gamma 2. And since CBA equals CAB, then we have that beta minus gamma 1 equals alpha minus gamma 2. Which means that beta minus pi halves plus theta 1 equals alpha minus pi halves plus theta 2. Which means that beta plus theta 1 equals alpha plus theta 2, and therefore beta minus alpha equals theta 2 minus theta 1. So there we have the two relations we needed to have between angles theta 1 and theta 2 and angles alpha and beta. So we have that theta 1 plus theta 2 equals alpha plus beta, and theta 1 minus theta 2 equals alpha minus beta. Okay, if we add the two, we have then that 2 theta 1 equals 2 alpha, and if we subtract the 2, we have that 2 theta 2 equals 2 beta. This means that theta 1 equals alpha and theta 2 equals beta. So we have that same sine of theta 1 equals a over d. That means a over the diameter of the circle. And we have that sine of alpha equals hc over b. And then we have that hc over b equals a over d. And then we have the ab equals hc times d. That means that the product of sides ab equals the height traced to the third side, which is c, times the diameter of the circle. We also have that hc over a, which is sine of beta, equals sine of theta 2, which is b over d. So hc over a equals b over d, which means then that ab equals hc over d. We also have that ha over c, which is the sine of beta equals b over d. And then we have that bc equals ha over ha times d. That sine of alpha equals hb over c, and hb over c equals a over d, and we have ac equals hb times d, and ab equals hc times d, bc equals ha times d, and ca equals hb times d. Okay, we're going to finish this up in the next video.